In this question, again, we have a consolidated-drained triaxial test. So we can write U is equal to 0. And it's mentioned that it is conducted on normally consolidated clay. So we know in sands and normally consolidated clays, the value of C prime is equal to 0. The value of sigma 3 is given to you, and the value of delta sigma d of failure. So this is equal to sigma prime 3 because this is a drain test, and the value of sigma prime 1 would be sigma prime 3 plus delta sigma d of failure. And now the question is asking for the angle of friction, the angle that failure plane makes with the major principal plane, and normal stress, shear stress on the failure plane. So as I mentioned in the previous questions, this is the equation between the principal effective stresses. Now, in this question, since the value of C prime is equal to 0, we don't have this part, and we can write, and from this equation, we have sigma prime 1 equal to 200 plus 400, which is 600 kilopascal. So using these two, we will have 600 is equal to 200 multiplied by this value, and solving this equation will give us phi prime equal to 30 degrees. So this was for part A. For part B, we're going to use this equation. Theta is equal to 45 plus phi prime divided by 2, which is equal to 60 degrees. This is for part B. And for part C, these will be the equations that we need to use. Now, if we substitute the values that we already determined, we can easily determine these values that are asked in this question. So we'll have 600 plus 200 divided by 2 plus 600 minus 200 divided by 2 cosine of 120, which is equal to 300 kilopascal. And for this one, we have 600 minus 200 divided by 2 sine of 120, which gives us 173.2 kilopascal.